I'm here with Sean and Bernie from Xandeum, and I want to know what these pNodes actually look like because, man, nodes are all the buzz right now, and everybody's trying to run one, but what do they actually look like?
Yeah, so thanks for that question. So the hardware requirements as of now are really quite low, right? But, I have to say these hardware requirements, they evolve over time, right?
Sure.
Once we go to mainnet, there will be a competition between the pNode providers and, some hardware that did work before, at some point it might not work. And I have that same experience right now with my Solana validators, by the way, right? So things change. But, right now you have the opportunity to run a pNode in our Devnet, in our incentivized Devnet, and the requirements are quite low. So you, with like 2 gigs of RAM, you're fine. Maybe even less. 2 virtual CPUs is fine. No special requirement, like maybe, a gigahertz minimum or something.
Wow.
So you don't need much CPU. And then you should be able to dedicate at least 64 gigabytes of memory, 64 gigabytes of storage to the Xandeum network. So if you have like an 80 gig drive or so, you use like 20 for the operating system, and you can dedicate 64 gigs to the Xandeum network, you're fine. So you don't need a ton of storage right now in the DevNet, and you won't even later on, right? It's just, if it's little storage, it's relatively little rewards, right? So it's going to be proportional.
How's the software deployed? I got to ask this because with the requirements that you just kind of covered, it sounds like I can get my Synology, device to actually run a node almost.
Oh, yeah, absolutely. Yeah, I think you can. Yeah. So, and with the software requirements, you install our pNode software there. We have it for Linux right now.
Okay.
Right? It should be running on, and I don't know, Synology probably has Linux, right?
They do.
Yeah. So that's fine. And right now we have it for Intel, AMD architecture. Many people want to run it on a Raspberry Pi.
Yeah.
That should be possible also. And you might be able to compile it for that ARM architecture. So that's all fine. And then you just install our software, and we made that super simple also, right? So you just have an Ubuntu instance, and then you just run our stuff. It will do basic things like making your SSH connection safe, disabling password login over SSH, just like hardening your system a little bit in order to run a pNode, because that will be a catastrophe if that's opened up to the world, right? And it sets up a tunnel for you so that from your PC at home, if the pNode is running somewhere else, you can tunnel through it and can access our GUI, our web app that is made so easy, that XanMiner software that shows you all the drives that you have. You just have that slider, how much to dedicate. You click on dedicate to Xandeum. That's it. You see your rewards adding up there. You can generate your new key and register your pNode and everything. So it is super, super easy. And our software is those 2 components. It's the XanMiner software. It's that admin interface that's made super, super simple. And there is that pod software that communicates with our Atlas, and which is kind of part of that decentralized storage network that we have. And that's where the actual data is stored, and that's where the fast communication takes place between other pods or between Atlas and even the docs that we have on these RPC nodes. So the pod software is where, the heavy lifting of storage is happening. And even that doesn't need a lot of RAM. So with those 2 gigs of RAM, you can run both XanMiner and the pods. And yeah, all you need is a fast and reliable internet.
All right. You took a lot of the work out for a lot of people, because that's half of the battle is getting your system, to be secure. It's getting that tunnel to be set up. That's a pain for a lot of us that are setting up nodes. Having that taken care of through your software is a huge deal.
Absolutely, yeah.
Well, I mean, if we want thousands of people to run these pNodes, we need to make it easy. So that's the first priority for us: secure and easy. That's what we need here at Xandeum.
Yeah.
So what's it going to look like in DevNet? Are we going to have, thousands of nodes out there, or are we going to limit?
Yeah, so our DevNet is starting out now in the Deep South era. We're going to do 300 pNodes, max 3 per wallet, by the way.
Okay.
In the Deep South era. Then we have the South era, right, with the fully working prototype. Still no mainnet traffic or anything in the South era, so we want to drive that up to maybe like 1,000.
Okay.
And
what will people be able to do though by the time we get there? Still in DevNet, I mean, we're not talking about mainnet yet. Are people going to be able to actually build and leverage that storage layer for their apps?
Oh yeah, they can build their apps already while we're on DevNet, and they can test them out on DevNet, and they're going to be working apps, and they do that in parallel until we launch on mainnet with the Frankfurt release, right? Relatively early. It's like, I don't know, the 7th or 8th release that we do in general. That's going to be out there in mainnet, but you can build your apps in the South era on DevNet, because with the very first release of the South era, the Munich release, everything's there. All the API that the apps are using, right? They have their own instructions that they can send to the storage layer, right? So you can make it. First of all, you create your world. That's the file system, right? That you use. We call that instruction the Big Bang instruction, right? It creates your universe, right? And then you can do mkdir, right? That's create directories. And then you can create files in there. And then you can read and write from those files, right? Read and write, we found those terms really boring. So for us, it's called peek and poke, right?
Love it.
So with the poke instructions, we write something to the file, and with the peek, we read it back. It's kind of a nod to my early years when we used the basic programming language, right? It had peek and poke as well, maybe.
Yeah. I'm that old. I remember.
Okay. So we have that peek and poke, and we call it peek, poke, prove even, right? Because there's those Merkle proofs that I talked about that are being generated, the Solana validators being able to challenge those pNodes, so to kind of verify those proofs. So it's peek, poke, prove, and yeah, at some point, if someone wants to destroy their whole file system and just close out the app and get back everything they paid in order to set up that space, we have an Armageddon instruction that destroys the world. Right?
Wow. All right. What is a Merkle proof for those that don't understand what those are?
Yeah, so that would probably be another video or so. The Merkle proof is basically, cryptography is all about hash functions, right? So hash functions are functions that take a piece of data and then create basically something like a checksum, right? So a checksum is something that's shorter than the original data, but somehow the checksum shouldn't be telling you what the original data was. It's kind of unidirectional, right? It's easy to calculate this way to create the hash or the checksum of some data, but it's not easy having the hash to figure out what the original data was, right? And that's where all the math comes in. What are good hash functions and stuff like that? I envy these kind of mathematicians and out there and stuff. And it's a lot of Israelis that did that stuff. I mean, back in the day, it was the Germans that did it, right? And now, so don't want to get into history here. But all these hash functions. And then if you make hashes of hashes and stuff like that, right, then you can build a tree, right? It's called that Merkle tree. So you have the data in the bottom, and then you hash it, and then out of these hashes, then you have maybe 256 blocks of data. You have 256 hashes. Then you hash these hashes together, and then you're only at if you take two of those, then you're only at 128. And then one level above, you're at 64. And then you have in the top what's called a Merkle root, right? And that has some nice properties, because if you change anything in the middle or so, you just need to take that path through the tree, and you don't have to do everything again and stuff like that. So these Merkle proofs have these cryptographic properties, right?
Now that you explained that a little bit, this can make it very easy for you to answer this question. What happens if bad actors get a hold of the data?
Oh, yeah. So that's obviously something that's being taken care of on several levels. It's not that the Xandeum storage layer per se is kind of encrypted. It's going to be an optional type of thing because it costs, right? Sure. And the Solana accounts, they are completely public, right? Yeah. Anyone can see anything on there. We have that optional encryption layer that we put on top of that. And also, you need to understand that all the data is chunked, right? And we call that paged. We call these chunks pages. And that we borrowed that from Unix memory management, right? So it's called a page, and in Unix it's, I think, 4 kilobytes or something. Ours will be a bit larger because obviously it's an exabyte system, so a page is likely going to be a megabyte or something. But then everything is stored on these. It's like a tile, right? Every tile is same size, right? But the data is all chunked into these pages, so the pNodes typically will not really know what files they are storing, right? They just have pages, and there's data in there, and it's not like consecutive pages are consecutive contents of a file or something like that. They store it all redundantly, and with that optional encryption layer on top of that, you will not be able to figure out what's in that data. And what happens if people get a hold of that data, that depends on the app, right? And with many apps, it won't be that critical, right? If we do the Wikipedia and people can read what's in there, well, that's kind of... You
actually want people to get the data.
Yeah. That's exactly what we're going for.
But there's other apps, obviously, where that would be super critical. So that's why we have that optional encryption layer in there. Yeah.
All right, Sean, what do you foresee people building using, the Xandeum platform here?
Oh my gosh. That can be a whole video in itself, to be completely honest with you. But let's go over what we mentioned already. Wikipedia, Uber, maybe the next YouTube, anything that can host, that can store data-intensive apps. Maybe a gaming type of browser-based application, something like that. We want to build the infrastructure so that the creativity from the community and for everybody that's developing on Web3 can thrive. So unfortunately, I'm not part of the app creativity team, but man, the sky is endless.
Yeah, we have a separate channel for that on our Discord, by the way. So sign up for our Discord, and we're collecting ideas there. One of the ideas that I find especially intriguing that I want to mention here is AI and LLMs, right? We have all these LLMs out there. And with the advent of DeepSeek and stuff, so we have LLMs out there, and we don't know, are they maybe compromised?
Yeah.
I mean, the first question is, are they biased? Most of them are in some way or the other. But the other way is they might even be with malicious intent being compromised by state actors and stuff like that.
Sure.
Right? So how do we keep those LLMs in check, right? What we need there is those LLMs actually signing their responses. That's one of the big things that I'm fighting for. And, I'm going out to all these LLM providers and tell them, well, if I use your API, at least optionally, I want to have your response signed, right? Because otherwise I have Grok, ChatGPT, you name it, Claude all out there and just telling me something, and I can never prove, I can take a screenshot and tweet it and say, Claude told me this, right? But it can be doctored, right?
There's no real verification.
Nobody can tell, right? And I think that won't stay that way. I think all these LLMs, if they want to survive, there will be competitive pressure to at least optionally sign their responses so that I can prove this is what came out of ChatGPT on that date on this response.
Yeah.
Once we have that, we can collect that. We can send challenges to all these LLMs, right? And have a suite of challenge questions like what happened on I forget that name in Beijing. That was it, Tiananmen Square or something like that.
Yep.
Yeah. So we'll ask that question.
DeepSeek won't know what happened. Nothing happened there.
Yeah. Nothing happened there. So and there's a lot of other, what happened on 9/11 or you name it, right? And then store that in the Xandeum storage layer. Have it administered by a DAO, right? And challenge all these LLMs. I will be super excited for that, but it won't work without those LLMs actually signing their responses.
Yeah, but I do love that a lot of times is the storage providers, like the pNode runners, are going to be the ones that are going to be not calling the shots, but essentially providing their feedback, saying, hey, I would love to see this. I would love to see that. I will tell you that node runners are your biggest fan base. Like if I run a node, I want to tell the world that I'm running that node, and I want to make sure that other people are doing the same. And talk about the pressure with the LLMs. Right now, we have already seen that, right? We see LLMs now explaining how they got to that final answer. They explain the thought process behind it. Yeah. They kind of walk you through it. So like you're saying, it's just a matter of time before, the people actually expect that signature saying this is verified, this is true. What can we do to get there?
Yeah. And I think, AI safety is still a big thing. We don't want to kind of stifle AI innovation, of course, but somehow we need to make sure it's safe. And having that in a decentralized app with challenging all these, that could be one of those apps.
Oh yeah,
right. So much for your question. What apps could be out there? There is, and gazillion types of apps, and it's real. That's why I like that term of Cambrian explosion, right? It's like there will be so many apps that we can't even think of today. And that was, by the way, the case in 2015 when Vitalik came up with the Ethereum idea, and obviously he was being asked like crazy, what is that being used for, right? It sounded like a geeky type of thing that nobody really needs, right? And Vitalik said, well, I don't know, right? It's just, I just put a general purpose world computer out there and let's see what people build, right? And he had a few examples like prediction markets and stuff that turned out to be true, but it's such a universal tool.
Yeah.
Same thing with AI, by the way, right? What could it all be? And then suddenly we had agents and we had that reasoning where they give you their thought process and stuff. Who would have thought that 2 years ago, right? Yeah. It's like we don't really know, right? But we just put a really, really versatile tool out there that's enabling to do everything decentralized. And decentralization is a trend. Not for everything, of course. There's so many people that say, well, nobody needs decentralization, but we do need it. Otherwise, crypto wouldn't be there. And we're at how many trillion market cap today? A few trillions, I believe. And that's all only because of decentralization. Because if it weren't for decentralization, we wouldn't need all that crap, right?
No, absolutely.
Yeah.
And I think node runners are the ones that really, really love the idea of being self-sovereign, being able to actually own their data, to be able to actually, do things on their own without a third party telling them where to go, where they can't go, and really having control over their lives. So having the ability to actually have real storage on the blockchain is a game changer for all of us.
Absolutely.
Well, I really, really want to know how we're going to get this done. So stick around and we'll get another video out for you guys explaining exactly how these pNodes are literally going to change the way blockchain is looked at.